Hi everyone, welcome back to Math Hub by Mr. H. And in this video, I will discuss one of the applications of derivatives, which is tangent and normal lines. So before we jump straight into the very first example, let's recall some important concepts about tangents and normals. Alright, so let's take a look at some diagrams here to explain further what tangents and normals are. Alright, so for this diagram above, so we have here the curve, and tangent line is the blue line. So tangent line touches the curve at exactly one point, and that's point M. Alright, and we can call that the point of tangency. Every point on the curve has a tangent to it. On the other hand, we have what we call the normal line. So the normal line, as you can see from the diagram here, the normal line is perpendicular to the tangent line at a point of contact. When you hear the word perpendicular, so the next thing that comes to mind is right angles. Alright, so to further understand how derivatives are applied here, let's take a look at the very first example. Example 1. Find the equation of the line tangent to f of x equals square root of x minus 3 at the point where the tangent line is parallel to y equals x plus 1 divided by 5. So the first thing we need to do is to find the derivative of the given function. But before we do that, we can rewrite this to exponential form, which is x to the power of 1/2. And then we can proceed with finding the derivative. So f prime of x equals, so we will be using the power rule here. So we bring down 1/2, copy x, and then for the exponent, we'll have 1/2 minus 1. And for the second term, which is a constant, so the derivative of any constant is 0. Then we simplify this. So f prime of x equals 1 over 2 times x to the power of negative 1/2. And then we can rewrite this. So f prime of x equals 1/2. So this one is negative. If you want it to be positive, then we put it down to the denominators, which is equal to 1 divided by 2 square root of x. Alright, so this is the derivative of the given function. The next step is we need to use this equation to find the slope. So we need to find the slope first of this line that we can use later on in identifying the x-coordinate of the point of tangency. Because if you take a look at the question, definitely we were not given the point of tangency. Alright? We can rewrite that into x over 5 plus 1 over 5. And from here, you can see that this is in slope-intercept form. So definitely the slope of this line is equal to 1 over 5. So we need that information because we need to find the value of x in which the derivative is going to be equal to 1 over 5. Alright, so we need to set up an equation here. So 1 over 5 equals to the derivative, which is 1 divided by 2 square root of x. Then we solve for x here. So you see we can do cross product. This will be 2 square root of x equals 5. Then we divide both sides by 2. This is going to be 1. So square root of x equals 5 over 2. And what we need to do is we need to square both sides. So this one gets canceled out, the root. So we'll have x equals to 25 over 4. So this is now the x-coordinate of the point of tangent C. Okay. All right, so in order for us to find the y-coordinate of the point of tangent C, we will be using this value of x to be substituted to the given function. So we have y equals square root of 25 over 4 minus 3. So let me continue my work here. All right, so y equals square root of 25 over 4. So square root of 25 is 5 over 2 minus 3. So y is equal to, so 2 times negative 3 is negative 6 plus 5 divided by 2. So negative 1/2. Negative 1/2 is the value of y. Therefore, the point of tangent C, let me write it over here on top. The point of tangent C is 25 over 4, comma, negative 1/2. All right, since we already got the point of tangent C, then we can find the equation of the tangent line, which is parallel to the given equation of the line here at this point. Okay. All right, so I'll be writing down the solution over here on the lower left. All right, so in finding the equation of the line, you will be applying here the concept of how to find the equation of the line using the point-slope formula, because we will be substituting the value of the slope, the x-coordinate and y-coordinate of the point of tangent C to be able to identify the line. All right, so the point-slope formula of the equation of the line is y minus y sub 1 equals m for slope times x minus x sub 1. So x sub 1 and y sub 1 are the coordinates of the point of tangent C. All right, so we'll have y minus, or it's going to be y plus 1/2 equals, slope is 1 over 5 times x minus 25 over 4 for the x-coordinate. This is already the equation in point-slope form, but it will always be dependent on what is needed, because you can be asked to write the answer in point-slope form or slope-intercept form or standard form or general form. Okay, but we can continue this until we find the equation in slope-intercept form. All right, so for this one we'll have y plus 1/2 equals, so we distribute, so we'll have 1 over 5x negative 25 over 20. So we can change this to 5 over 4. So y equals 1 over 5x. So minus 5 over 4 stays the same. However, positive 1/2 will move to the right-hand side, which will make it become negative 1/2. All right, so to continue, we'll have y equals 1 over 5x. All right, so negative 5 over 4 minus 1/2 is equal to negative 7 over 4. This is the equation of the tangent line. All right, so if you think that this question is interesting, hit the like button. If you haven't subscribed yet to my channel, please do hit the subscribe button as well. And let's head on to the second example. All right, guys, so for this question, we're asked for the equation of the normal line to this at this point. All right, as you can see from here, x and y variables are mixed together. All right, so I'm pretty sure you know what to do with this to find the derivative of this. But if you haven't watched my previously uploaded video about implicit differentiation, you can check out the link later in the description box if you need a little bit of refresher for this. All right. First, we need to find the derivative of the first term. We will be applying the product rule. So first, we take the first factor, x squared. Then the derivative of the second factor times 2y y prime plus we take the second factor, y squared, times the derivative of the first factor, which is going to be 2x. So this is the derivative of the first term, plus derivative of the second term is 1, minus derivative of the third term, which is 2y y prime, equals the derivative of constant is 0. Alright, next thing to do is to simplify the left-hand side of the equation. This one will be 2x squared y y prime plus this one is 2xy squared plus 1 minus 2y y prime equals 0. Alright, so in order for us to find the derivative or the y prime, we need to put together the terms with y prime on one side of the equation, and the rest that do not have will be on the other side. So that means we're looking at this and this term. So we just copy it. So the other two terms that do not have y prime, we move to the right hand side. And the next thing we need to do is we need to factor out y prime from the left hand side. So if we take out y prime from here, from this term, we will be left with 2x squared y minus, so taking out y prime from here, we'll have 2y left equals negative 2xy squared minus 1. Alright, and we divide both sides by this whole thing because we only need y prime on the left, and that's what we're solving for. Alright, so this will be cancelled out and will become 1. So definitely we'll have y prime equals the whole thing on the right hand side. We just copy everything. Okay, so that's actually the derivative. Alright, so the next thing we need to do is we will be using the x-coordinate and y-coordinate of the given point to be substituted to the derivative so that we will know the actual value of the slope at that point. Alright, so we substitute 5 for x and 2 for y. Alright. To find the value, we simplify this. Alright, negative 41 over 96, the slope value. So we can find the equation of the normal line now. But you have to take note, the slope is negative 41 over 96. For the normal line, we need to get the negative reciprocal of that. Alright, so the negative reciprocal of this value is 96 over 41. And this 96 over 41 will be the slope that we will be using in writing the equation of the normal line. Right? So we're going to be using the same point slope formula. Alright, so y minus y sub 1 equals m for slope times x minus x sub 1. So y minus y sub 1 is 2. The slope m is 96 over 41 times x minus x sub 1 is 5. Alright, so this time we can write the equation in standard form. Alright, so since we already got this set up, I can multiply 41 to the left hand side. So it will be 41 times y minus 2 equals, so 96 will be multiplied here. So we apply distributive property here. So since x is positive here on the right, then we can put the terms with x and y on the right hand side. So it will be 96x minus 41y equals negative 82 plus 480. So we simplify the left hand side. It's positive 398. And this is the equation of the line in standard form. Alright guys, so this is all for this video. If you find this video helpful to you, so give me a thumbs up, share the video, and if you haven't subscribed yet to my YouTube channel, please do so that you won't miss any of my future videos. Once again, this is Mr. H, and thank you very much for watching this video, and I will see you in the next one.